Hello everyone and welcome back again. In this lecture I will show you the solution of the previous example. In the beginning I make the load classification. I classify the load to the three category of the load which we were talking about in the previous lecture. For the critical load I choose the workstations outlet and the IT racks and everything related to the IT or a communication system. And for the essential load, I chose the three elevators and the fire pump, in addition to the first panel, which feeding the normal power and the lighting and the FCUs, fan coil. And for the non-essential load, also I'm selecting the water pump and the landscape lighting, in addition to the HVAC system. And this is the single line diagram which I have designed specifically for the previous example. As you see here, I have a line come from a medium volt side, and here I have a transformer, and here this is the MDBs, and here I have a set of backup generators, and here this is the ATS system, and all of this are sub main or sub main distribution panel SMDB. Here from the output of the transformer into to the MDB, I have three output, one to the submain number 1 and another for submain number 2, and here for here for MCC panel, and here submain 1 and here submain 2. And here I have the first load, which is non-essential load, the outcome or the output going directly from the transformer. See here from the main DB, I going directly to the load, which is the MCC for the HVAC system, and here for the outdoor lighting or landscape lighting. And after that also I have here output going to the ATS system, and from the generator also we go to the ATS system, and after that I'm feeding two panel port, one for the essential load, and here the another, as you see here, the output coming from the ATS directly to the UPS and to feed the another submain DBs or SMDB. And here I back to my previous example, and as you see here, the critical load is a panel port which is feeding the workstations and the outlet and the IT racks, and the essential load is the elevators and the fire pump and the first panel which is feeding the normal power and lighting and FCUs fan coil, and the non-essential load is the water pump and the landscape lighting and HVAC system. And also here, as you see, the non-essential is the HVAC systems, in addition to the water pumps and in addition to the outdoor lighting. And here also I have the essential load, the three elevators, and in addition to the funnel port which is feeding the normal power and the lighting and the FCUs. And here the critical load, I name the panel port here UPS. This panel port is feeding also all the items which is related to the communication or the IT systems. And here I will start to describe or explain this single line diagram, the details of the single line diagram. See here in the beginning I have from the medium volt side I have here the main unit, and here you can notice that the size of the switch gear here is less than the size here on the low volt side. Why? Because as you know, the relation between the volt and the current is inverse relationship. And after that here I'm going to transformer 1000 kVA delta star. The impedance is 6% and the medium volt side is 13.8 kilovolt, and also the secondary output is 400,000 volt 400 volt for 3 phase and 230 for the single phase. And after that here I have a switch gear, and it also I have a sensor for earth leak relay, and the size of the switch gear is 1600 ampere trip and 1600 ampere frame. And here also I have the measurement for my panel. This is 80. This is the current transformer ammeter to measure the current, and here also I have the voltmeter to measure the volt, and here this is the indicator's lamp. And after that here this is the main DB, main distribution panel. Here on the MDB the main breaker is 1600. I cannot adjust MCCP because as we in the previous lecture we talk about this point. Here the range of the MCCP is up to 1000, and after that I will going to the air circuit breaker. I have here 5 output for my panel, 1 spare and one going to the ATS 1000 ampere trip air circuit breaker, also 1000 air trip and 1000 ampere frame. And here I have also MCCP 630 going to the non-essential load, and here I have a spare. Also I have a breaker 80 going to the outside panel or landscape lighting. And here to enhance from the power factor I install the capacitor bank, and here to size the capacitor bank you can for all 1000 kVA I can choose 340 kilovar as a capacitor bank. Also I will attach for you one file. I made it for one factory designed for this capacitor bank or power factor correction. And after that here this I size the 2 generators to make the load sharing, and all of them is 250, and to run those generators together in parallel of course I required a synchronization panel. And here inside the synchronization panel the outgoing breaker will be also air circuit breaker 1000 ampere frame and 1000 ampere trip. And here I have 2 sets of cable, both of them form 4 core 240 millimeters plus 240 millimeters for grounding earth conductor. And after that from this ATS I have the fire pump. Also I consider this fire pump as essential load, and I have 2 panel ports, one of them for essential, which is the panel port feeding the power and the lighting for indoor. And here another going to the UPS unit. Here 120 kV UPS system, and from the outgoing from this UPS system is feeding this SMDB number 2, and from this SMDB I'm feeding my panel port which is installed for one for every floor, and after that from this final distribution panel I'm feeding my IT and communications outlet, power outlet. And here also see here this is a cable here to take this lines from a section, center line, to calculate the distance from the MDB to the final distribution panel. And as you know, it is important to calculate the volt drop. And here also on the elevator, for the elevators on the essential load, the cable is for multiplied by 16 mm. And finally here for the non-essential load I have the MCC panel, and here I have the water pumps, and after that on the roof also I have two outdoor unit BCCU, all of them is 75 horsepower, and the cable for each one is 4 core 70 millimeters, and the cable which is feeding this panel port HVAC distribution panel is 4 core 300 mm plus 150 mm. I will attach this drawing. You can review by yourself, and you can use it as a guideline for your next single line diagram design. Thank you for watching.